So for such a function, we know how to differentiate using the product rule, but we can also find natural log y equals natural log of this product Let's continue here. Anyone remembers natural log of a product? So I should have brackets here because this says the natural log is applied to the product. If I keep it like this without brackets, you may think that, oh, she's applying natural log to the first quantity and not to the second. So that's why here brackets are mandatory. Okay, so can anyone tell us what to do with natural log of a product? What is the rule for natural log of a product?
1 over the product?
No. This is algebra. Natural log of a product.
Would it be natural log of one product times natural log of the other one? Plus?
Exactly. So natural log of x to the third plus 2 squared plus. If it's division, it's minus. If it's product, it's plus. Natural log, you are not distributing. This is not a distributive law. This is one of the properties of log. Natural log of x squared plus 4 to the fourth power. Okay, now we apply a rule that we applied it tonight. What is it? Power in front, 2. Natural log x cubed plus 2 plus 4, natural log x squared plus 4. Completely simplified. Now I will differentiate natural log. And you already told me many times 1 over y times dy over dx. And now let's differentiate this. 2. Can anyone give us the derivative of this?
Would that be 1 over x cubed plus 2 times 3x squared?
Brilliant. Thank you very much. Plus, can anyone give us the derivative of this? It's the same thing, right? 1 over
1 over x squared plus 4 times 2x.
That's it. And now dy over dx, I'll multiply both sides by all that. You can say this is not easier than using the product rule. Yep, I agree. But I just want you to see the method. So dy over dx. So I multiply both sides by y, all that. X to the third plus 2 squared, x squared plus 4 to the fourth. And now I have to use a bracket. So this is 6x squared over x cubed plus 2 plus 8x over x squared plus 4. So this is another way of determining the derivative. Any questions? Any questions? Okay, I think that this is as far difficulty level as I can think of, especially not beyond this for a test. So I would like us to look at a simple problem and then word problem, and then we'll stop. So the next section just deals with applications. So all this was technique: product rule, chain rule, logarithmic differentiation, implicit differentiation. These were just techniques. Now we have them ready, handy, and what do we do with this? So applications. I'm hoping that you will find 3.7 the easiest of all. Okay, so we have a ball is thrown vertically upward with a velocity of 80 feet per second. Then its height after t seconds is given by s of t. So this is the height, and this is 80t minus 16t squared. What is the maximum height reached by the ball? So obviously this is a quadratic function. It has a negative leading coefficient. So I'm throwing the ball from this height. It reaches a maximum and it hits the ground. So this is the maximum height. We know how to find the maximum for a quadratic function, but I would like us to do more than just that because this is algebra. So we're asked, number one, find the maximum height. And part B, what is the velocity of the ball when it is velocity? When it is 96 feet above the ground. When ball is 96 feet. So, I don't know, here, 96 feet. And it says above the ground, on its way up and on its way down. Okay, so this is an anticipation of the next chapter, basically. Obviously, the slope of the tangent line here is positive, here is positive, here is positive, smaller and smaller. What is the slope of the tangent line at the maximum?
0.
Yes, slope of the tangent here is 0. And then it's negative and it's negative, blah, blah, blah. Okay, how will I determine the maximum height? Not with algebra. The maximum height will be determined by setting the derivative equal to 0. How come? When I set the derivative equal to 0, because that's the slope of the tangent, I will find this x value. And then I can determine the y value. Now, if you ask me, find the rate of change here, then I have to find the derivative, but somehow you have to give me some other information to plug it in. But this is the easiest thing, finding the maximum or finding the minimum, because the slope of the tangent line is 0. What function gives the slope of the tangent line? The derivative. So I have to find s prime of t. Can anyone give us s prime of t?
minus 32.
Good. And then I will set it equal to 0. And then I move 80, well, let me write it. 80 minus 32t equals 0. I move 80 and divide by negative 32. When I move, it will become negative and divide by negative. Of course, time has to be positive. So 80 divided by 32. I'll simplify by 8. And I'll simplify by 2, so t equals 2.5 seconds. Notice that this is not the maximum height. This is the time from the moment I throw it up in the air till it reaches the maximum, and that is 2.5 seconds. How do I determine now the maximum height?
S of t.
Very good.
S of
2.5. Awesome, awesome. Thank you very much. So all I have to do, I'll say the maximum height is s of 2.5, and that will be 80 times 2.5 minus 16 times 2.5 squared. I don't know what that is. I'm sharing my screen. So I get, if you have the number, don't torture me, please give it to me, times 2.5, and then minus 16 times 2.5 squared, and I got the height 100. And 100 must be in feet. I'm looking, yes, feet per second, yes. So the velocity is given in feet per second, then this is feet. Okay, so that solves the first question. Number 2, they're asking us to find the velocity when the height is 96. Velocity, I already have it. This is the velocity function. But I don't know the time. I have to find the time to plug it in the velocity function, and I'll give the velocity. But I need the time that the ball needs to reach 96 feet. How do I do that?
Do we do 96 equals 80 minus 32t?
That's the velocity. It doesn't say, so this is the height. The height equals 96 feet. So the height is 96. I have to set this equal to 80t minus 16t squared to find the time. Move everything to one side, it's quadratic. So 16t squared minus 80t plus 96 equals 0. Yes, you can simplify, but let me show this with the calculator. Very simple, it's factorable, but I just want to show how to determine. Go to apps, and this is right here, number 9. It's a polynomial. Yes, it's degree 2, or if it's another, it's called order in the calculator, but it's degree. So choose the degree, but it's already 2 in there by chance. So I think I have to click on graph. So the first coefficient, the leading coefficient is 16. The next coefficient is negative 80. The next coefficient is 96. And I guess click on graph. I get x equals 2 and x equals 3. I'm fine if you determine. I'm not interested in showing quadratic formula anymore. You're in calculus. I'm happy if you just give me the solutions. If you want to factor and simplify, yes, I would have done this. I would have simplified both sides by 16 and then factored. So obviously the situation is this. The ball is going up and then hits the ground. Somewhere here is 96 because here is 100. Of course, closer, but that's not important. So it takes 2 seconds till this point, and it takes 3 seconds till this point. Okay, so this is 2 seconds and this is 3 seconds. Okay, so all I need to determine is the velocity. So s prime of 2 and s prime of 3. So we have 80 minus 32, so 80 minus 64, and 80 minus 32 times 3, 96. So this is 16. And what is the measurement unit for velocity? The distance was measured in feet, and time was measured in seconds. And I should have written here seconds. So what is the measurement unit for 16?
Feet per second.
Thank you very much. And here we have negative 16 feet per second. So why? This is on the way up. The direction is positive, the slope is positive. Here's on direction now down. So this is the slope of the tangent line at this point. The slope is negative. It only says, it tells us direction. I cannot drive at negative 16 feet per second. It just says direction.